Okay, welcome to another short video of OpenStax Astronomy. We'll be looking at Chapter 13, Comets and Asteroids, and kind of the debris left over in the solar system. So 9.1, we'll first talk about asteroids and meteors. So most meteors are just pieces of asteroids. So asteroids are pretty much leftover debris from the solar system. Most of the debris turned into the planets. And so we're talking on the inner part of the solar system. Most of these asteroids are going to be kind of metallic, rocky substances. And so if a piece breaks off of an asteroid, we call that a meteoroid. And so that's typically if an object is out in space. If that object comes through the Earth's atmosphere, so crashing down on us, we call it a meteor. And that's typically what people think of as a shooting star. Then if it doesn't get all burned up, if it's large enough and it makes it through the atmosphere and it actually falls onto the ground, then we call it a meteorite. But they are all part of the same object. It just depends kind of on its path of where exactly it's at. Here are some images of asteroids. And so notice that they're not large because they are more potato-shaped. So gravity doesn't have any influence to make it spherical all the way around. And that's how we typically could see if objects are very large or small in space. The main place where these asteroids are concentrated are in the asteroid belt. So beyond the orbit of Mars and before the orbit of Jupiter, there's a lot of debris in there. And so we think that perhaps was going to be a planet that formed, but those objects ended up colliding with one another, and so they keep making a lot of debris. So majority of these asteroids are going to be concentrated in the asteroid belt. You do have a few that are kind of in front of the orbit of Jupiter and some that are behind, which we call kind of those Trojan asteroids that also follow along the orbit. But a lot of that debris is kind of between Mars and Jupiter. We see that a lot of these objects, we're looking at orbital resonance. So if you recall the moons of Jupiter, how they synced up when one would do one revolution, another would do 7 exact revolutions. So we see this kind of resonance here. So objects that are in resonance with exactly 1/4 of the orbit, or 1/2, we see that there are actually very, very few in there. We get these dips here. So what happens if they're in orbital resonance, then they line up with a Jupiter that has a gravitational tug on them and pulls them a little bit to make their orbit a little bit more elliptical. And when that happens, then those end up crashing with other asteroids. And so you get a lot more debris. So it's really Jupiter that caused or stopped from anything forming in the asteroid belt. Every time objects try to get a bit large, you have a lot more of these collisions because of Jupiter's gravitational influence. And we see that these meteors come in several types. There's so primitive meteors here, so kind of rocky material. They're going to be rich with some of these carbon compounds. And then also these processed meteorites, which are going to be made of iron and metals here. They kind of resemble these volcanic rocks. Here we see some objects. These are actually the moons of Mars, so Phobos and Deimos here. And we see that they are not exactly spherical, right? Kind of slightly potato-shaped. Still fairly large. We could see Phobos here on the left is almost spherical. So these are really just captured pieces of debris. So they didn't really form at the same time as Mars. They just got captured in its gravitational pull, and now they orbit around it. So we talk about Jupiter, Saturn having like 70 plus moons. A lot of that is just going to be some of that debris that they've captured, these kind of large asteroids. So what about asteroids and planetary defense here? There's a lot of talk about, asteroids coming to Earth and just kind of, annihilating life as we see it. Possibility, but very unlikely here. Here it's Meteor Crater, Arizona. 50,000 years ago, an object about 50 meters wide impacted here. Very large, even with erosion happening here and wind. The large portion of the hull still remains here right after 50,000 years. So a very, very large object. This was in the early 1900s in Siberia. Meteor actually had exploded right before it hit the ground and leveled this entire forest. And here's a more recent one in 2013 in Russia here. We see that object covered on caught on someone's dash cam. This also came flying in, and when it collided, the energy released with it was about 30 times larger than the nuclear bombs dropped in World War II. So we're talking a lot of energy, a lot of power with these objects. We get bombarded every day with asteroids, but most of them are small and get burned up in the atmosphere. But every now and then, we have a few that make it through and are very, very large. So here we see kind of on a scale here on impact size relative to time. So something that would be kind of a mass extinction here would probably be once every, 100 million years to once in Earth's history. So these mass extinctions, these large asteroids that would impact us are going to be very, very rare. In fact, if we're saying that there's probably only one in Earth's history, we believe there's already evidence that this happened one time. And so a likely impact site here is in the Yucatan Peninsula. And so we believe this is this impact site of a meteor that hit about 65 million years ago. That is what it was something probably about 10 kilometers in diameter. That ended up extincting the dinosaurs. So initially, when it hit there, it kind of hit part water, part land. Anything in the vicinity there, was instantly killed. Huge tidal waves there. But what happened is so much debris got thrown up into the air that sunlight got clouded out, and then vegetation died. Then vegetarian dinosaurs died, and then carnival died. So it was fairly rapid, but it didn't happen instantly on that impact there. And so we see some evidence of this with a thin, rare element of iridium that is only found on these asteroids here. And so we see that there's a dinosaur fossil line here. So we don't see any of these fossil lines above that layer. So when the debris went up in the air, dinosaurs started dying, and then all of that sediment kind of came down, and it created this kind of layer there. And so we see that throughout when we look at dinosaur fossils, that that line there is of that iridium. And so that gives us evidence that there was something that had a lot of iridium that contributed to the death of the dinosaurs. And we know that's found in asteroids. So what about comets? Well, comets are leftover debris, but typically they are on the outer part of the solar system. And so it's a lot colder, so they are kind of more of dirty snowballs. And so the nucleus isn't too large, but as they come in, the solar winds start melting them slightly and pushing out a lot of their dust, and they have these huge plasma tails. And so when a comet is coming towards and away from us, the tail always points away from the sun because it's the solar winds that kind of that interact with that cause that tail to be created. Here we see kind of an orbit of Charon's orbit here, which was a comet. And the key thing is that it is highly, highly elliptical here. this orbit right about here. So highly elliptical orbits, and that's pretty common of what we find with these comets here. So outside of the asteroid belt, we have the Kuiper belt, where we see that Pluto is part of. That ranges from about 30 to 50 AUs. And their orbits are fairly elliptical. But there is another outer region called the Oort cloud that extends out to about 50,000 AUs. And so there are other objects that have highly elliptical orbits that take very long periods for those to orbit around. And if you ever looked at a meteor shower here, what happens is as a comet passes through its path, a lot of that debris gets thrown off. So when the Earth goes through that path there, it will go through all of that debris, and it burns up all of those particles that makes a spectacular meteor shower. Here we're looking at a comet that was going to collided with Jupiter, and so we see that it had a highly elliptical orbit, and as it came in, Jupiter's gravitational influence moved it out of its trajectory path and then caused it to kind of change its path there. So it was kind of this more of a hyperbolic path, and then it became very elongated here, very elliptical there. And we see this here, the Shoemaker-Levy 9. We could see some of the impacts there. So Jupiter's gravitational influence kind of pulled that towards it or changed its orbit, and then it collided with Jupiter. And we could see here the impact. This is the big red spot. Remember, that's about 2 to 3 Earths. And then you could see some of these impacts here that are about that size. So this would have been what we consider probably a global annihilator there. And so it happens that Jupiter, because its large gravitational pull, actually protects us from that, from these large comets that come, or large objects that come in the inner part of the solar system. Jupiter has really acted as a shield for us. So typically Jupiter has that huge influence, and it's able to throw a lot of these objects or project them out back into the Oort cloud. And so this is why we have that other area beyond the Kuiper belt that has these highly elliptical orbits, because it's typically a lot of things that are ejected outwards. So it's kind of more like a sphere around us of these comets that are orbiting in all directions. So the main clutter in our solar system is asteroids in the asteroid belt. Then we have comets in the Kuiper belt, and also comets in the Oort cloud. And so Pluto meets a lot of these conditions where it was much smaller than the 8 planets here. It's on the outskirts, but it wasn't a gas giant. And it's mainly icy composition. And it has a very elliptical orbit. At times, it was inside the orbit of Neptune. And so Pluto has more in common with comets than it does with the planets. And so we think that Pluto is perhaps an oversized comet, and that is why we no longer consider it a planet.